Okay, in this video we're going to talk about finding the maximum and minimum values of our quadratics. In the introduction, I told you that the minimum or the maximum always happens at the vertex. So if the vertex is the highest point, it's going to be the maximum. If the vertex is at the lowest point, it's going to be the minimum. And then the important part that you want to remember is that when we're asking for the maximum or the minimum, we're only asking for the y value. So once you find the vertex, the only part that you actually need is going to be the y value of that. Okay. And these images just remind you, if A is less than 0, it's going to be a reflection. If A is greater than 0, it's going to open up. That's going to help you know if it has a maximum or a minimum. So example 4 says, tell whether the function f of x equals negative 4x squared minus 24x minus 19 has a maximum or a minimum. When I'm asking you to tell me that, the first thing I want you to do is draw a sketch. So I want you to look at the equation and tell me what's the value of a.
Negative 4.
Negative 4. Is negative 4 less than 0 or greater than 0? Okay, so since negative 4 is less than 0, I know that it's going to open down like this. So that means it's going to have a maximum. So when I'm asking, does it have a maximum or a minimum, that's all of the work you need to show. That's it. Show me that you know that you looked at negative 4, you saw that it was less than 0, so you knew that it opened down, just like with the absolute value graphs that opened down. Then if we want to find that value, we have to find the vertex. And in order to find the vertex, we have to find the axis of symmetry. So we're going to repeat those steps that we did when we were graphing. We're going to first find the axis of symmetry using our formula, x equals negative b over 2a. Be really careful with your computation on this part, because if you make a computational error on the axis of symmetry, then when you plug it in, the other answer is going to be wrong. So be really careful with these. Generally, the numbers are pretty nice. So we have negative 24 divided by 2 times negative 4. So negative 24 is 24 divided by negative 8. So our axis of symmetry is x equals negative 3. Put that in a box so I know what it is.
Negative 2 times negative 4, isn't that positive?
But the 2 isn't negative. When you have a negative in a fraction, the negative is either with the top number or the bottom number. It's not with both.
But negative 4 times 2 is, oh yeah, I get it now.
Okay.
Wait, so technically, if you wanted to, could you put it on the bottom and do negative 2 times negative 4 and get
Technically,
positive
yes.
8?
Technically, yes. We never do.
Okay.
And
then,
it wouldn't change the answer.
and then also, what if the fraction that you get, is it like, I don't know.
A nice fraction.
But it doesn't like, simplify to a whole number.
Then you just have to use the decimal or the fraction.
Okay, so would you just simplify it down?
Yes.
Are we
Yes.
gonna have questions like that?
You will have some. They will generally be, usually they're the word problems where the numbers don't come out to be quite as nice. But you'll have, when that happens, you'll also, if the numbers are bad, you'll have a calculator. Like if the fraction is 25 over 32, you'll have a calculator to use. So now we're finding the vertex. We're going to take that negative 3 and plug it in everywhere we see an x. We're going to be careful when we square a negative. So when you're doing this, go ahead and square -3 first. I would do as much of this in your head as you can. I wouldn't use a calculator until we get to the really ugly numbers. So -3 squared is 9. 9 times -4 is -36. And then we have a negative times a negative, which is a positive. When you're doing 24 times 3, you can come out to the side and write down 24 times 3. Remember your, yes, it's 72. Remember you're multiplying. Like 3 times 4 is 12. 3 times 20 is 60. So 12 plus 60 is 72. And then minus 19. So f of -3. So -36 plus 72 is positive 36. Minus 19 is 17. So the maximum that we said it has is 17. We only want the y part of that. So we can see that the vertex, if I wanted the vertex, it was -3, 17. But if I want the maximum is just the 17 part.
So, on the minimum, you still only want the y, right?
Yep. Either way, minimum or maximum, we only want the y part of it. Okay, so now we have a couple of word problems. We're going to start with example 5. It says the suspension cables between 2 towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by this equation. If possible, sketch a picture of what might be happening there. So we've got 2 towers, and then we've got a cable. And look at is your value of A positive or negative?
Positive.
Positive. So we know that our cable is making a parabola that opens up. So it's something that's doing like this between those 2 towers. How do I know when I sketch that it's going to be a really, really wide parabola instead of a really, really narrow parabola? Yeah. That value of A is tiny. It's really close to 0. And the closer it is to 0, the wider that parabola was going to get. And that's just something that we know from when we graphed absolute value graphs. It does the same kind of a thing. So then it says where x and y are measured in feet, the units are going to be important. What is the height of the cable above the water at its lowest point? So lowest point means we're looking for a what? A maximum or a minimum? A minimum. Circle that lowest point. And so now we're going to use the same steps we used in example 4. For this, only the numbers are going to be lots uglier, so we're going to want to use our calculator for this. We'll start with finding the axis of symmetry. Write your formula, x equals -b over 2a. Write it every time. So x equals negative 37/100 divided by 2 times that lovely number there. There's 4 zeros after the decimal and then a 9/8. Go ahead and punch that in on your calculator, see what you get. Okay, so if you just do the denominator first, which is not how I would do it, but if you do 00098, it's going to tell you this. That's the calculator's way of writing scientific notation. That e just means times 10 to the -4. So remember with scientific notation, if that exponent is negative, then to take it out of scientific notation, you would move that decimal to the left. So that means it is 0.000196. But we don't really need that. We just need the final answer, right? So instead of doing it like that, I would type in my numerator first, so 0.37 divided by, and then since we want the multiplication to happen first, do parentheses 2 times 0.0000098, close parentheses. If you don't put those parentheses, it's going to divide 0.37 by 2, and then it's going to take that answer and multiply it by the other. And that's not the order that you want. And so it should be something like this.
Negative 188.
Try typing it in the way I typed it in.
Wait, that's what I'm saying.
Something's different.
Are these the type of numbers going to be like
These are fine numbers. Yes, these are perfectly acceptable numbers. We're going to go ahead and round to the nearest whole number. So that would make this 1,888. And that's our x.
So we're going to see like a lot of these numbers?
When you see word problems, you're going to see decimals. And decimals are no harder to put into a calculator than normal numbers. So don't look at them and worry about them. Just say, okay, that's just the number I plug into the calculator. It's going to be fine. Now you're going to take that number and plug it back into the equation to find the vertex. So you're going to do y equals 0.00098 times 1888 squared minus 0.37 times 1888 plus 552. And that's what we're going to plug into our calculator. Right there. So I'm going to hit clear, and I'm going to type it in just like that. 0.0000098 times 1888, close parentheses, squared, minus 0.037. Oops, thank you. Not 0.037, just 0.37. 1888, close parentheses, plus 552. So about 203 feet. So the calculator did all of the heavy work for us there.
So can we just do this, like on our test, can we just do the little squiggly line equal sign?
Yeah, that's fine. And on a test, I would probably tell you what to round to specifically so that we've had some consistency in our answers.
Just after
Yes.
this like last 4 problem, are we going to go into the quadratic using x intercept?
Not today. No, this is the last piece, and then we're just going to practice with basic numbers, finding the vertex, using the axis of symmetry, and using that to find the vertex. Yes.
Can you? I keep getting a negative.
Okay, let me help you in a little bit. Let's do this one. If it's a calculator help, I can help you once we're done.
Does it matter if the exponent is inside the parentheses or not?
It will if the number that you're squaring is negative, then it will matter.
Okay.
So I would always put it on the outside. Okay, I want you to read this question to yourself first, and then I want you to read it again and write down anything that's important. So, in this one, you've read it, you know that they're launching water balloons. They gave you a function, so that function is going to be important. I would write it down. F of t equals negative 16t squared plus 80t plus 5. When you look at that, you need to know which one of those variables represents x and which one represents y. So which one is being squared? T. So t is your x value. And what does t represent?
Time.
Yeah, it says t seconds, so t is the time. And then f of t is which variable? That's your y value. And they tell you in the problem what f of t represents. And they say it like this. Here's the function, blah, 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 and it represents the height. that means f of t is the height. So that means y is the height of your balloon. Before you start a problem, you need to know what's your x, what's your y, and what do they represent. That way, if they ask for kilograms, you know if kilograms was the x or the y value, so you know which one they're asking you to find. Yes?
Why can't they just write X and Y?
Because in science and in the real world, it's really nice to have variables that represent what you're looking for. Like when I'm doing area problems and I'm using length and width, I use L and W.
Then why don't they just
So they use T for time. And then it's a function of, height is a function of the time. And so that's why they write it that way. Yes?
if we're doing height, is the F or whatever always for the height?
It is. If you're talking about an object that's being thrown into the air, often. Not always, but often. Yep. And you'll see a lot of problems like this. And you'll see them again in physics. So this will give you kind of a good starting foundation for that work that you're going to do next year.
Is every single thing that's like thrown parabola?
The time, if you're looking at the time versus the height, yes. The actual placement of the object is not necessarily a parabola. But if I plot it's how high it is off the ground over a period of time, the graph is always going to be a parabola, yes. Okay, it says the second height of the water balloon, t seconds after it's launched, is shown in the graph. So they already gave us this over here. This is the second balloon. Can we see how high it went?
Yes.
Well, here's our time. Here's our height. What does each tick mark on this graph represent?
15, 25.
25. And so 25, 50, 75, 100, 125. It's a bit over 125, so probably the height is about 130 feet.
They threw that water balloon
At its max.
130
They
feet.
launched it. So we don't know what they actually launched it with. They could have used like a slingshot kind of a thing that you pull back and launch it. Lots of different ways to launch things. Okay, then we want to know which one went higher. We know this one went 130 feet. That means we want to find the what of this.
The height minimum.
We want to find the highest point. That would be the maximum. So we're going to find the maximum.
Did we already find the maximum?
So this is the first balloon. Let's label that. That would have been a good thing for us to write down initially, especially when you have two things happening. That this is the first balloon and this is the second balloon. So I'm going to give you a few minutes. I want you to find the axis of symmetry, and then I want you to plug it in and find the height. You're probably going to end up with a decimal on this one, and that's okay. Okay, so what we did here was we found the axis of symmetry. We used our negative b over 2a. It gave us a decimal. As long as your decimal is nice and it is a terminating decimal like 2.5, that's fine. If it's a repeating decimal, you need to use the fraction instead. So if we had gotten 1/3, we would not use 0.3, we would use 1/3. Okay? And then we plug that in to our equation, and we found that the maximum height of our first water balloon was 105. And so if the question is which one went higher, the second water balloon went 130 feet. This one went 105 feet. So we're going to say the second water balloon went 25 feet higher. So when you're doing those word problems, remember the key things are to read the problem, read it again, write down the important information, be sure that you identify what the variables are. Which one is your x, which one is your y, and what do they represent? Time, height, speed, distance, whatever. Be sure you know what they're representing. All right, that's the end of that.